Sounds like a blast.
Well, I'm down to 2 hours of sleep at night because we're at the end of the trimester and proctoring SAT, PSAT, and other stuff. So there was no sleep. I eagerly await death, as that's the first thing I say on the video that's being shared. Hey, kids out there on YouTube land, if you can become an engineer or a research scientist, I right now, if someone asked me, would you rather die or teach another high school class? Pretty close on the. Well, I don't want to say it because yes, teaching's fine. Ignore me, kids. All right, so for each of the following compounds, identify whether they are constitutional or conformational isomers. So the first thing you want to do is figure out what's the difference, right? So a constitutional isomer means that they have the same molecular formula, but they have different connectivity. A conformational isomer means that you just kind of rotated them. So if you can see my camera screen, right? So these are my headphones, right? And so if I had another set, like my, as I drop them, my wireless earbuds, right? These would be constitutional isomers. They're both earbuds. They both do the same thing. One's wireless, one's wired, right? So these would be constitutional isomers. They're the same thing, but they're assembled differently. Now, a conformational isomer is when you have the same thing, but you just kind of move it about. So like you can just rearrange it. So if you think about a chair flip, if you draw your structure in a different way, anything like that, those are conformational isomers. Does that make sense? You guys understand the difference between the two? So the easiest way, if you get stuck in a problem, do you guys have a strategy to figure out if something's a constitutional isomer or a conformational isomer?
I usually count the number of carbons, and that's it.
Yep. So in this problem, if you only have two choices, you don't have to worry about that. If one of your options is neither, then yes, count the carbons. That should be the first thing you do. Also, the easiest thing you can do is name the compound. If you name the compound, you get up with the same name. So 1, 2, 3, 4, 5. This is 2-methyl propane or pentane. And then if I do the same thing with this, right? So 1, 2, 3, 4, 5. This is also 2-methyl pentane. All right, so if you name them and you get the exact same answer, then that means that they are the same molecule, right? So that's how you tell the difference between them. All right, so that is my easiest recommendation. Use something that you can very easily do and it shouldn't drain you. If you can't name them very easily, then feel free to move on. All right, so let's go ahead and try and name the second one. So in the second one, I can automatically see that they are different. So in the next one, right, here, I have 1, 2, 3, 4, 5, but I have 2 methyls coming off of 2. I have 1, 2, 3, 4, 5, and the 2 methyls are coming off of 3. So these would be constitutional. Does that make sense? Yep. All right. So now let's go to the last one. I'll let you guys try this one real quick and see what you can come up with. What do you guys think? Constitutional or conformational? You want to be able to identify quickly. I've already identified it. Faster, better.
It's the same molecule?
They're the same molecule. They're just arranged differently. So that's conformational. Bless you. Question, Megs?
Yeah, I thought it was constitutional.
So
Because
if
they
I
look different. Because, like, isn't there, like, a group coming out of, like, the third carbon? But then when you look at the other compound, it's coming.
wait, hold on.
out
Did
of-
I miss? Nope. Yeah. So basically, no, I did this right. So 1, 2, 3, 4, 5, 6, 7, right?
Mm-hmm.
And then 1, 2, 3, 4, 5, 6, 7. Oh, wait, hold on.
Continued. I have a really quick question.
Yep. What's up?
Do you have to count the chain the same?
Remember, what's always the same thing when you do stuff like this?
Or be consistent.
Consistency.
Okay.
Consistency. So 1, 2, 3, 4, 5, 6, 7. So this here is your 7 carbon chain, right? Coming off of carbon 2 is this. And coming off of carbon 3 is a methyl. Going to the other one, coming off of carbon, sorry, that number is wrong. This is not 2, that's not 3. This is off of 3 and 4, right? And then this is off of 3, and this is off of 4. You guys see that? So these are conformational. They just are basically kind of just flipped. Mags, do you still see that?
Yeah, I just counted the carbons this way instead of this way.
So this is something that you should do, is think about if you ever get to this type of problem, what you did is fine, but try counting it the other way and see if you get the same thing.
Okay.
Right. So just that's probably the easiest way to do that. All right. Any questions on that? You guys feeling okay? I'll do what I do in my high school class. We're doing great, Dr. V. You're the smartest guy ever. Okay, so which pair of the following compounds are constitutional isomers? So what's the easiest way to do this? So a constitutional isomer has the same what? Structure or molecular formula?
Molecular formula.
Yep, so what I would do is in this type of problem is count the number of carbons that are present inside that molecule. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 8, 10. So my answer should be 2 and 3. Does that make sense? And that's the easiest way to do it. Just count the number of carbons. If you end up with the same number, try it again and see if there's anything like that. But that's basically it. Okay. Excuse me.
Bless you.
Thank you. I got my second COVID shot Friday.
It's not COVID. It's good.
Maybe I'm dying of COVID. I had a good run. I've had 3 types of watermelon. Talked to a girl once. What more do I need? Okay, so draw a Newman projection of the following compound down the indicated bond. So this is probably one of the trickiest skills you need to do, but I always like to think if I'm taking this compound, right, I'm going to rotate it, right, to look down. So the first thing you should always do, and this is something I do, is that I come in and say, this is my dot. The first carbon that is in your line of sight is the dot carbon. The carbon that's directly behind it is the circle carbon. So then, and then I will color code it like that. So, okay, so the first one is my dot carbon. So I draw my dot first, right? And then I draw my circle behind it. Does that make sense for how to distinguish between the two? So if you're looking, if wherever that arrow is pointing, the first carbon that arrow is pointing out is your dot. So what is attached to your dot carbon?
Chlorine.
Chlorine. What else? There's 2 other things there.
Hydrogen.
A hydrogen. And a CH3. Don't forget that, right? Okay, so if I'm looking down that carbon, right, what I should draw first is in plane. The in plane is going to be your easiest one, right? So that, which one is that? The chlorine, the hydrogen, or the CH3? Which one is in plane?
The chlorine?
Nope, chlorine's a wedge, right? If it's a dash or a wedge, it means it's either coming out or going into the page. So in
So is it your
plane is
hydrogen?
just a straight one.
Oh, okay.
Does that make sense? Right, so you draw the in plane one first, all right? And so for this, all we're gonna do, now if I'm looking down that bond, right? So if I'm looking at it, and I'll turn my camera on again. If I'm looking down it, right? Is that methyl going down or is it going up?
Down.
It's going down. So I'm going to come in here and draw the methyl coming down like this. All right. So now, if this is my molecule and I rotate it, because it's like flat right now, but I'm rotating it, I want you to, this is something I do, is that take your hand with your thumb and put your thumb pointing at you. Okay, so which way do you have to rotate your hand so that you're looking down the correct side? So if you're looking at, if this is where the arrow is pointing, right, and you want to look down it, do I have to turn this way or this way?
This way?
Yep, so is your thumb pointing to the left or to the right?
To the right.
Should be pointing to the left.
Oh.
Is that your left? So here, take your right hand, everyone. This is going to be counterintuitive because the camera's backward. Take your right hand. Put your thumb towards you. Okay, so is the arrow coming from the right to left or left to right? It's on the paper. Look on the paper. Is your arrow going from right to left or from left to right?
Right to left.
It is going right to left. You guys need to know direction. This is so very important.
I didn't realize I was muted. Oops.
So it's going right to left, right? So if you want to look at your back of your hand, which way do you need to turn it? This way or this way? So now when you do that, which way is your thumb going, left or right?
It's pointing left.
Should be going left. Mags, you're flipping your hand in a very awkward way. Take your hand like this, Max. Is that your right hand?
Yes. No. Yes.
Okay.
This is my right
Now
hand.
you want to, so which way is the arrow going? Right to left or left to right on the paper? Look at it. Don't look at me. Look at
Right to left.
Okay. So do you want to look at the back of your hand then, right? Because you're going right to left. So how would you turn your hand to look at it? Look at the back of your
Like
hand.
this.
Which way is your thumb pointing?
Left.
Okay. So which way should I draw my chlorine then?
Left.
Left. All right. So now once I draw that chlorine, what's the only thing left now?
Hydrogen.
The hydrogen.
Okay. And now this is something very important. That hydrogen is what? Dash, wedge, or in plane?
Dash.
It is dash. If you do this, this is going to have an added effect here because now, which way is that bromine on the back one? It's a what? Dash, wedge, or plane?
A dash.
It's a dash. So it's going to be going the exact same way as your hydrogen, right? The dashes have to match up. The wedges have to match up. All right. So on the back one, the methyl that is coming off, this is in plane, right? Is it going up or down?
Up.
Up. So now what's the only thing left?
The hydrogen.
Yep. And that it has to be on a wedge because that's the only thing we haven't seen. So then it's going to be this. There you go. Does that make sense?
Yes.
I want you all to come back to this and practice this again. All right. Take a picture, draw it as this is, put it aside, come back to it after your brain's forgotten and try it again. All right. That's what I always, so what I recommend is put your hands in front of you like this. All right. And so if your arrow is going left to right, you're going to use your left hand. If your arrow is going right to left, use your right hand. Right. So right to left, right, left to right, left, whatever one comes first, right? Whatever the arrow is pointing at. So whatever hand you're using. So if I was to do the left to right, so imagine I'm looking this way, right? On this carbon, and I'm going to use green. This is just a thought exercise. So don't panic if you're like, what's he doing? All right. Imagine I was looking this way. All right. So which hand would I use? My left hand or my right hand?
Left.
Left hand. Okay. So which way is the bromine pointing? Into the page or out of the page?
Out.
So take your pinky, if it's the dash, and point it away from you. So now if you want to look at that, which way do you have to turn your hand? Do you want to look at the left side of your hand or the right side? You're going from left to right, so you want to look at the left side. So now if you turn it, your pinky is going to be going to the left, which is what you would have if you look that way. So this is where you use your hands to help you out. All right. What is the first thing you should do if you are directionally challenged at the start of every question like this?
Hands.
When everyone makes a left, an L is your left hand. Do that if you are that directionally challenged. I promise it'll help. Something you should also do is that if you get stuck, do this. Literally label left and right so you keep that straight. I promise it seems silly, but just keeping your cardinal directions should be fine. Right? Any questions on this one?
I do have a question.
Mhm.
I think you mentioned it in the beginning, but how do we know like where if our like the CH3, the one that's coming forward on the Newman projection, how do we know that's not like it's not like flipped like vertically? Do you know what I'm trying to say? Like
So there are two
it's not
there are two CH3s here. Now I'm going to circle them, and I want you to tell me which one you're talking about. The red
So
one or the blue one?
oh god, the blue one.
Okay. So imagine you're looking down there, right? Imagine you're looking straight down,
Mm-hmm.
right? So
Oh,
is the methyl coming down or up?
that's going down. Oh, okay.
Does that make sense?
Yeah.
I mean, you can always
Okay.
draw an eye if you want.
Okay, yeah. Sorry, I get it now.
Well, that's fine. If you got it right off the bat, people like me wouldn't have jobs. Okay. Let's go to the next one. 3. Draw a bond-like structure for each of the following. So does it matter if I flip this to the left or to the right? Or either one will work? What do you think? What if I always told you about all of these 3D structures? It doesn't matter if it's left or right, just as long as you're.
Consistent.
Okay, so the first thing I'm going to do in this one is something that you should also do is I'm going to color code I'll color code in some way. So the dot one I'm going to make blue, and this one I'm going to make red. And the reason for this is so that when I do this and I flip it, I can keep track of it. All right, so this is going to be a little bit tricky, and we will walk through it. Sorry. Messages. Worst thing about being online is that kids are constantly messaging you. There is no escape. Okay. So which one, if I was to imagine I have my hands are my 2 carbons, right? It doesn't matter. So what I want you to do is put your left hand in front of you and your right hand behind it. Okay, so imagine these are your 2 carbons. So you have your left hand right in front of your face and your right hand right behind your left hand. Your left hand is what color, blue or red?
No, wait, what hand? Your left hand?
Your left hand. Your left hand is at the
Blue.
blue because it's the first one you're looking at, right?
Mm-hmm.
So now here is something that's going to be a little tricky to do, but once you get it, it's going to make sense. When I have this compound, I need to rotate it so that it's flat, right?
Mm-hmm.
So imagine you are turning your hands, and I'm just going to kind of grip my thumb so that I'm turning it so that my blue carbon ends up on my left side. Imagine you're just rotating your hand so your left hand is on the left side. Right? So I'm just rotating like that. So my blue carbon is going to be on the left, my red carbon is going to be on the right. Does that make sense?
Mhm.
Okay, so what I do to do this first is that I simply come in here and I say blue carbon connected to red carbon. And you may be saying, but Terry, can I do it the other way? And you sure can. It doesn't matter as long as you're consistent. But just imagine left hand, right hand. Imagine turning it so that your left hand or the blue one is to the left, right? I always try to keep my directions the same way so that I don't confuse myself, right? If I did it the other way, now my left hand is on the right hand side and my right hand on the left hand side, and that's just very confusing. That's why I always try to keep my hands, whenever I do something like this, ordered. Okay, so attached to the blue carbon is what?
Hydrogen and 2 CH3.
Yep, I have two CH3s and a hydrogen. So I always like to just keep them nice and organized. So then I'm going to draw this here. So I have CH3. That keeps happening. I don't know why. Try cleaning my screen. and hydrogen. So if I'm looking at it straight down, which one of those is in plane as my bond? The CH3 going straight up, the CH3 going to the left, or the hydrogen going to the right? Which of those is in plane with the bond that I just drew right here?
Is it the CH3 in the middle?
Well, I mean, which direction is it pointing? Up, to the left, or to the right?
I don't know.
I mean, look at the picture. Which
Oh,
CH3?
so the CH3 pointing to the left. Sorry.
Nope, that's not in plane.
Okay.
When we drew the last one and we drew them in plane, did we draw them to the left or to the right, or up or down?
Up or down, right?
Up or down, right? So that CH3 here, this is a very important thing. If it is in plane, it'll either be up or down. Okay. Because imagine, take your hand like this and imagine your fingers, right, are pointing up as this is your bond pointing up. If you turn it, is it still in the same plane as your hand? Yes, right? It's still in the same plane. So anyone that's pointing straight up or straight down, those are the ones that are always in plane. So on my blue carbon, is that arrow going to be going up to a CH3 or down to a CH3?
Up.
It's going to be going up. So it's going to be going to CH3. Now, on the other side, what's going down off of the red one?
The CH2, CH3.
Yep. Does this make sense? Right? If it's up or down, those are in plane. Okay. Now, let's go back to the blue carbon. Do you want to do the hydrogen or the methyl?
Hydrogen.
Okay, so if I'm looking, like, put your left hand out, because that's the one we're going to turn, and take your thumb to the right, just like the hydrogen is, right? Now turn your hand so your thumb's facing, so turn your hand this way, because that's the way we did our rotation when we were rotating it. Which way should my hydrogen be coming? Pointing, should it be pointing out on a wedge or in on a dash?
Dash.
Dash is going in or out of the page?
Out.
It should be on
In.
a wedge.
Should be on a wedge. Wedge is out. So if you take your hand and you rotate it, your thumb is pointing at you. It's on a wedge. Does that make sense? All right. So that means that this is going to, keep this color coded. This will be the hydrogen. And then the only other thing left is the dash, and that has to be the CH3.
Just to confirm, for the hydrogen, you start with your thumb to the right because it's on the right side in the.
Yep. So whatever way you rotate, right? And also, yeah, my thumb, because like if you place your hand in front of you, right, and which way is the hydrogen going in the drawing?
To the right.
Okay, so should you use your pinky or your thumb if you're looking at the back of your hand? Put your hand over the picture, like literally just put your hand over the picture right now. Which way is the hydrogen going? Should I use my pinky or my thumb?
If I'm looking at the back of my hand on my left hand, then my thumb.
Yep. So then that's why, because remember we did this, right? And we rotated it. So think about how you're rotating it.
Okay.
So this is why if I'm doing this, it's pointing at you. You have to be consistent with that. But here's really the key part. Even if you make a mistake on the left one, what should be the one thing you always do to make sure that you don't make a dumb mistake here? You always want to match. So these two should be coming off of the same side. So that means that the hydrogen's on a wedge. This CH2, CH3 should also be on a wedge, right? Because they're both going to the right. Does that make sense? Because this is part of the be consistent. If they're going to the right, they both have to be Like it doesn't, even if you make a mistake, they both have to be the same thing, whether they're both dashes or they're both wedges. Does that make sense? So then these CH3s on the left, since they're both going to the left, it doesn't matter. Like if you make a mistake at this point, better you be consistent with your mistake, right? Because if, say you flip them, you're going to be wrong no matter what. But as long as you're consistent with the drawing, even if you're unsure of how you did this, you at least better your chances. Does that make sense? Okay. How are you doing with this?
Okay.
Better.
Better, yeah, definitely
Okay.
better.
This just takes practice. And like I said, is this something that that someone can be inherently good at, or does it need a lot of practice?
Practice.
Both. You're either really good at it or you need practice. It's a very unfair thing. I am very good at this. And this is one of the reasons why I did well in this class. It's just that I don't have to expend a lot of brain energy to do this. And it's really unfair, but such is life. So now, what type of structure is B?
A ring?
Are you sure about that?
No.
Are the carbons connected in a loop?
Sure.
Start on one carbon and see if you can end up back at the same carbon.
Okay.
Morgan, Mags, what do you think?
I don't
Not
think so.
Okay, I want you to start at the circle carbon, right? So this carbon here
Mm-hmm.
goes to here, and to here, and to here, and to here, and back to here. Did I end up back at the original carbon? So the
Yeah.
only way that can happen is if it's a
Ring.
ring. So it has to be a ring. Does that make sense for why those connect? So how many carbons are in my ring?
Wait, 1, 2, 3, 4,
5.
6.
There are 5.
3,
So you
4,
have
5.
1, 2, 3, 4 for the dot carbon, 5 for the ring carbon. So there are 5 there. So what should be the first thing you do when you figure out it's a ring?
Draw the ring.
Draw the ring. Draw a 5-membered ring. 1, 2, 3, 4, 5, like that. All right. So here is now something that I also like to do is again color code. This dot carbon I'm going to make black. So you are my dot carbon. And so if I'm looking this way, that means that my ring carbon is this one back here. Right? So on the dot carbon, there's a CH3. Is it going up or down?
It's going up.
So it is going to be a dash or a wedge.
It's going to be a wedge.
Yep. So remember, when you draw rings, they're a little bit differently. You just care. You don't care necessarily if they're left or right or whatnot, because remember we can do chair flips. This is going to be a wedge because it's going up. So now if I look at the back one,
Isn't that just going to be, oh wait, never mind.
it's going to be a dash.
Doesn't matter where you put the dots.
Mm-hmm. What do I keep telling you?
Consistency.
Consistent. So imagine I go from my dot black to my blue, and then I'm going like this, right? Which way am I going? So imagine, so Max, take your hand and go blue, or go black, which is in front, and then blue's behind it, right?
Mm-hmm.
So I want you to take your hand. So imagine your thumb pointing at, take your left hand, put your thumb pointing at you, and your pinky's away. So thumb is your front carbon, your pinky's the back carbon. Am I going to go to the right to come back, or am I going to go to the left? Looking at this picture.
To the right.
Yep. So if I go to the right, I'm going like that. So I have to be consistent that way. Does that make sense?
Yes.
So that's why you have to pay attention to that. Okay, I want you guys to try and work on the next one by yourself for a minute or two, and we'll see what you guys get. All right, so is this a chain or a ring? Or are you guys still working on it?
The ring.
All right, so this is a bit tricky, so follow along if you can. That's it.
Oh.
It's a
Wait,
six-membered
how many
ring.
carbons did you have?
So for every dot and circle, right, how many carbons are those? The dot and circles are 2 carbons, right? So 2 here, and then 2 in the middle. So that's 6.
Okay.
I sense that you're not happy with that answer.
I counted 8.
Okay, so I'm going to ask you, we'll start here at this dot. Right, so then if I'm going this way, this is 2, right, the one in front.
Okay, yeah.
And then 3 for this dot, right? And then going back to the ring is 4. And going back to the back carbon is 5. Coming back to this ring is 6. And then back to the dot where I started, so I don't count that one, so that's only 6.
Why didn't you count it like when you got to the, like when you started at the first carbon? Why didn't you count like where it intersects with like the ring? I mean, with the circle.
Because that's not a different carbon.
Okay.
So real quick, I think that's you, Morgan, right? The dot carbon, take your left and right hand in front of you. Your left hand in front, your right hand behind it. The dot carbon, is that your left hand or your right hand?
It's your left hand.
Okay, so if I'm counting and I go this way, am I going through my backhand? I'm not going to, it's only if I go straight back do I count this, right? It's just there. So it's what you're seeing is that circle is your front atom. That's your front carbon. That circle is your front carbon.
Okay.
Right? And the carbon behind it is blocked. You can't see it. So the dot here, so when you see this, right, and you see things coming off of it like this is just one carbon atom. You can't see what's coming off behind it. The only way you can see what's coming off behind it is like this. So that ring represents the second carbon, but it is still part of the first one. Does that make sense?
Okay, yeah.
Okay. How you guys doing? Gwen, you look a little...
I think I'm doing okay. It's just like, I'm one of those people where I can't just do it, so.
Practice, right? So this is what I found is that everyone has about a good 2 hours inside their head for when they need to do this practice, and then you have to take a break. That's just, your brain can't function thinking about that for a long period of time. But we're going to take a quick break because my time is up for this first session. I need to use the restroom too. We'll come back. I know, Gwen, you said you have to leave a little early, but we'll keep continuing if you want to come back for a little bit before you have to go. What was it? Work? Fight a hobbit? I don't remember. Beat up Ellie? All right, so we'll come back in a couple of minutes. I just need to use the restroom. It's the same link for the thing. We'll come back and we'll continue this. I'll be back in a couple of minutes. See you guys then.